Friends, welcome back to my YouTube channel. So in today's video we will see a problem of beam, how to analyze this by using the unit load method. So this is the given problem. So using unit load method or virtual work method, find the deflection at point C and take EI is equal to 410 into 10 to the power of 2 kilonewton per meter square. So this is our given structure. So in first thing what we have to do is we have to find out the support reaction of this beam. So here at point A it is having the in support. The possible reaction will be one will be horizontal and another will be vertical reaction takes place, and at roller support there is only one reaction takes place, that is our VD. So now we need to find the support reaction. Now we'll see. For that, summation of moment about A is equal to 0. Clockwise we need to take the positive. So here VD is moving anti-clockwise. So minus VD into at what distance it is moving from here to a distance is 9. So minus VD into 9 plus 1 UDL is acting there. 30 into at what distance it is acting? 5. From here to here is 5 meters. So 30 into 5. So UDL always act. If you convert UDL to point load, it comes here. So at what distance it is acting? From here to here. Here to here distance is 2 plus 2 plus 2.5. So here to here 5 meter. No, obviously from here to here it becomes 2.5. We need to see the from what distance it is acting. From here to here is total. If you calculate 2 plus 2 plus 2.5, it will come out as 6.5. So here point load is acting at a distance of 6.5 from here to here. So I have written 6.5 plus one more point load is acting. So it is also moving clockwise. So 20 into at what distance it is acting? 20 into 2. So plus 20 into 2 is equal to 0. Now solve it. So VD. So our VD is nothing but our x here. X into 9 plus 30 into 5 into 6.5 plus 20 into 2 is equal to 0. So our x value is nothing but VD. VD will come out as 112.77. It is nothing but 112.78. So write it here, 112.78 kilonewtons. So it is also going upward. So write it here, 112.78. The direction what we have taken is correct. Similarly for VA, summation of all the vertical forces is equal to 0. Upward forces we need to take the positive. Here V and VD is moving the upward. So VA plus VD value we got was 112.78 minus here one point load is acting. So it is coming downward means minus 20. So minus also UDL is acting. 30 into at a distance of 5. So 30 into 5 is equal to 0. So if we solve this, so VA is nothing but our x. VA plus 112.78 minus 20 minus 30 into 5 is equal to 0. Our VA will come out as 57.22. 57.22 kilonewton. It is also moving upward. So whatever the direction we have taken was correct. 57.22. Now for HA, summation of all the horizontal forces we need to take. Is there is any horizontal force? No. So our HA will become 0. HA value becomes 0. So this is how we need to find all the support reaction. So now what we have to do is, in question what they said to find the deflection at point C. So at point C we need to find the deflection. It means we need to apply the unit. So unit load of 1 kilonewton at point C. I will show you. We need to redraw the diagram. I will redraw it and explain it. So I have redrawn the diagram here. We need to remove all the external loads, whatever the 20 kilonewton and UDL is there. So I have removed it. We only applied the, so at point C unit load of 1 kilonewton we need to apply. So by removing all the actual loads. So from here to B distance is 2 meter and here also 2 meter, it is 5 meter. So now for this diagram also we need to find the support reactions. Here at point A hinge is there, hinge support is there. Hinge at hinge support the possible reaction is one is HA and one is VA. And at roller support the reaction will be VD, possible reaction will be VD takes place. Now we need to find the support reaction. So I will find it here. Summation of moment about A is equal to 0. Clockwise we need to take positive. It's moving anti-clockwise though. At distance from here to here is 9. So minus VD into 9. Minus VD into 9. So 1 kilonewton is moving clockwise at a distance from here to here is 4 meter. So plus 1 into 4 is equal to 0. So now solve it. Our VD will come out as minus x. X is nothing but VD into 9 plus 1 into 4 is equal to 0. Our VD value will come out as 0.44. So 0.44. 0.4 kilonewton. It is also moving upward. 0.4. Similarly for VA, summation of all the vertical forces is equal to 0. We need to take upward positive. Here VA and VD is moving upward. So VA plus VD value we got was 0.4. Here one unit load of 1 kilonewton is coming downward. So minus 1. It is minus 1 is equal to 0. So now solve it. Our VA value will come out as 1 minus 0.4 will be 0.6 kilonewton. It is also moving upward. So VA value we got was 0.6. So there is no any horizontal load. So VA HA value becomes 0 here also. So this is how we need to find the support reaction for this read-on diagram. So it is called it as the M1 and it is called it as the capital M. Capital M is nothing but moment of the actual diagram and our M1 is nothing but moment of this whatever the 1 kilonewton we have applied. So now what we have to do is we need to draw a table. I will show you. See here like this we need to draw a table. Here the member, origin, limit and moment capital M, small m1 and EI. So member is nothing but whatever how many members we have AB, BC and CD. So we need to write it here AB, BC and CD. So origin is nothing but for AB I am taking the origin as A and for BC I am taking the origin as B. For CD I am taking the origin as D. So I will tell you later why I have taken the origin ABD. I will explain while solving. For AB, limit is AB we have the distance 2. So our limit is 0 to 2. For BC also we have the distance 2 meter. 2 meter is nothing but our limit will become 0 to 2. For CD we have the distance 5 meter. So limit will become 0 to 5. So now for capital M, for AB, so what we have to do is, so whatever the origin we have chosen, we need to cut the section away from the origin. For AB I have taken the origin as A. No, we need to cut the section away from this origin. This origin means, so our section will come like this. Cut the section x-axis away from the origin A at a distance of x. So now here VA is moving clockwise. Now we need to take the which is moving upward, we need to take the positive, and which is moving downward we need to take the negative. So it is moving clockwise means upward. So 50, at what distance from this section it is moving? At a distance of x, the VA is moving. So VA into x. So VA value we got was 57.22. So 57.22 into x, our capital M becomes 57.22x. So we need to solve from this side to this side up to this section. Up to this section we have only VA is acting there. Now we need to see whatever the load acting from this member we need to see. So now for small m1, so origin is we have taken A. Now we need to see from A to B, only this section we need to see. So if you cut the section x-axis away from the origin A at a distance of x, here VA is acting upward. Now upward we need to take the positive. So at what distance it is acting from this section is it is acting at a distance of x. So 0.6 into x. Our m1 becomes 0.6 into x. Is there any load acting? No, only VA is acting. So now for BC, I have taken the origin as B. For BC, I have taken the origin as B. So it means we need to cut the section away from this origin. So our section will come like this. X-axis at a distance of x. We need to solve from this side to this side. So what happens if we take an origin as C, our section will cut like this, cut here, and we need to solve from this side here to here. So for easy calculation, I have taken the origin as B. Take origin as B. See here only VA is acting and 120 kN is acting. So here if we take our origin as C, our section will come here. Then we need to solve from here to here. Here VD is acting, UDL is also acting. So we have two choices. You can solve from this side and this side. According to the origin, you need to solve. So for BC, I have taken the origin as B. Our section will come here at a distance of Vx. So now see here VA is acting at what distance from this section? So 57 point VA into here to a distance is 2. VA into 2 plus here to a distance is x. So VA into 2 plus x at a 2 plus x distance, it is our VA is acting. So our capital M becomes 57.22 into 2 plus x. So it is also moving upward. We need to take the positive. So 57.22, it is acting at a distance of 2 plus x minus 1 point load is acting at what distance it is acting? It is acting at a distance of x. So 20 into x. So it is moving downward. Now we need to take the negative. So minus 20 into x. So minus 20 into x. Similarly for M1, if you cut the section x-axis away from the origin B at a distance of x, so at what distance VA is acting? So VA is acting at a distance of from here to here is 2 and here to here is x at a distance of 2 plus x. So 0.6 into 2 plus x. So it is also moving upward. Now we need to take the positive. So 0.6 into 2 plus x. So A value is 410 or same for all the member. So I will write it later. For CD, I have taken the origin as D. For CD, I have taken the origin as D. So our section will come like this at a distance of x. So now we need to solve the from here to here. So why I have taken origin as D means, see here we have only two load, VD and UDL. We can easily solve. If you take the origin as C, so then our section will come here. Then we need to calculate for this load and this load and this also from this side. For the easy calculation, I have taken origin as D. For CD, see here our VA is moving upward. No, we need to take the positive. So at what distance from this section it is moving means it is moving at a distance of x. So VD into x. So VD value we got was how much? 112.78. 112.78 into x. So write it here. 112.78 into x. So also UDL is acting there. No, it is coming downwards. So 30 into at a distance of it x. So 30 into x. So UDL always act at the distance of L by 2. L by 2 is nothing but our x by 2. L is nothing but length. So from here to here length is x. No, it is acting at the distance of x. It means x divided by 2. UDL always act half of the distance. Half of the distance is nothing but x divided by 2. So here 2 1 ja, 2 5 ja. So 15x square. It is also moving downward. Now we need to take the negative. So it will come out as minus 15x square. Minus 15x square. So write it here. Minus 15x square. Similarly for CD, M1, if we cut the section x-axis away from the origin D at a distance of x, so VD at what distance from this section it is moving at a distance of x, so it is moving upward now, so positive VD into x, so VD value we got was 0.4 into x. M1 is nothing but 0.4 into x. So this is how we need to fill this table. I hope you all are understood, this concept is clear for you. So now what we have to do is we need to find out the deflection. For that we have the formula yd is equal to integration of 0 to L capital M small m divided by EI into dx. Now I am taking 1 divided by EI, it is similar for all the members, I will put it later. So integration of AB, so limit is 0 to 2, no, 0 to 2 into this, so 57.22 x into 0.6 x dx plus integration of BC, so limit is 0 to 2, this into this, 57.22 2 plus x minus 20x, put the bracket here, and 0.6 into 2 plus x dx plus integration of 0 to 5, limit is 0 to 5, this into this, so 112.78x minus 15x square into 0.4x dx. So now by using calci we will solve it. So integration of 0 to 2, limit is 0 to 2 into this, 57.22 into x, close the bracket, again bracket, 0.6 into x plus this one, plus integration of 0 to 2 into 57.22 into 2 plus x, close the bracket, minus 20 into x into 0.6 into 2 plus x, close the bracket. So while entering the value we need to enter it carefully and close the bracket wherever it is. So if you miss one bracket you will get the error, so that it's very important while substituting all the values. So integration of 0 to 5 into 112.78 x minus 15x square, close the bracket, 0.4 into x. So now solve it, our YD value will come out as 1594.58. so write it here, 1594.58 divided by EI. So EI value we got was how much? We got was 410 into 10 to the power of 2. So now solve it, it will come out as 0.0388 meter or 38.8 into 10 to the power of minus 3 meter. So this is our final value. This is how we need to find the deflection at point C. So here our problem ends. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.